Okay, it is good to know that everyone are working professionals. Okay, so no one is a fresher, so that you could easily understand what exactly I am teaching today. Okay, fine. So whenever you are see, first of all, our idea is to, whenever you are planning to learn any technology, any process, any language, first of all, we should understand why is it required. So why DevOps is the question, correct, right? So let's try to understand why DevOps. In the process, you'll also get to know what are all the tools and the services you will be learning as part of this particular program. Okay, yeah. So why DevOps? So whenever you are working for an organization, definitely you work for a project. You get these projects from some clients. Am I correct? Clients also, most of the cases would be from some other organization. Now, these clients directly does not allocate or assign a project to one particular organization. Client would be verifying n number of organizations, and based on some considerations, they will be allocating or assign a project to one particular organization. Yes or no? Yeah. So now, what are all those factors is the question. Correct, right? So let's try to understand those first. So I would say cost effective. Yes or no? Whoever is little cheaper, then they'll incline towards that. The second one is fastest delivery. Whoever delivers it fast, definitely, just it's not that only you are little cheaper than others. You have to deliver it fast as well, right? Yeah, so that's also important. The third one is at the same time they look for quality, 100%, right? Yeah. So then if you are maintaining that application, always that application should be highly available. High availability matters for anyone. Okay, if the application is not available, since we are in competitive market, what will happen? If Amazon.com is not working, what do? We go to Flipkart, right? Any other, right? Okay, so people does not have patience. Okay, and why should they be? Correct? Okay, so now each and every organization wish to achieve this for, but for some reason it is not happening for all. So what exactly we do is we'll divide an organization into two teams. One is development team, and the second one is operational team. Who comes under development team? Developers, testers, project managers, whoever is responsible for delivering the project, they come under development team. Who comes under operational team? So these guys are admins. They will be owning the environments like test, UAT and production environments. And they are responsible for deploying the application into those environments. I'll definitely come back like what is an environment, what is development, deployment, all that I'll explain. But what my idea here is day-to-day life, these two team members would be facing some problems. Okay, so if you can able to identify the problems faced by these two teams and provide solutions to those problems, then we can achieve these four. Yes or no? Okay, there are some issues. That's the reason these are all not happening. So if you can able to identify the problems and provide solutions, then we could achieve easily, correct? So let's try to understand those issues. Before we do that, there are few technical terms I'll be keep using in this particular demo. Let's understand that, then we'll come back to these problems. Development and deployment. Development meaning there are some requirements, you got it from the client, okay, and you are writing some code and making it work in the developer system is actually called development. Deployment meaning, yes, it is running successfully in my system, but I wish to run it on some other system or a server or set of servers. Okay, just copying the files from your system to that system is not sufficient. You need to configure that system. Configure meaning you may need to install some softwares, update some software, provide some permissions, all that, right? So then making it work in that particular system is actually called deployment. Okay, so running the application in the developer system is called development. Running the application in some other system or set of servers is actually called deployment. Okay, development is running in the developer system. Okay, in some other system is deployment. Fine. Now environments. You will have environments like dev, test, UAT, and production environments. So environment, in an environment, you'll have set of servers and there your application would be deployed. Generally, multiple servers will be there because of high availability. Okay, we'll anyway understand that high availability again in detail. So, but why we are calling it as like environment is like set of people only will be using that environment. When I mention dev environment, developers would be testing the application in the dev environment. Test environment belongs to testers. So testers would be testing the application in the test environment. Then UAT environment, user acceptance test. So client would be validating the application in the UAT environment. If everything goes fine, then they'll allow you to deploy into the production. So actual users will be working on or using that production application. Okay, fine. Now we understood that. Now let's try to understand the problems faced by these two team members. Okay, development team. Under development team, developers will be working definitely. So what is the job of the developers? They write some code irrespective of the technology. It can be Java, it can be .NET, it can be Python, does not matter, but they write some code, correct? That code, we call it as source code. Yes or no? Source code. Now, where do they keep that particular source code? Initially in the developer system. I write code here, it will be there, okay, here only. Now, if we are keeping the code, when I say we developers are keeping the code in the developer system only, then the problems would be if that system get crashed, then they'll be losing the code. Then the second problem would be at some point we need to integrate the code, correct, right? So it's not like only one developer will be working, multiple developers will be working. So we should combine the code. So then each time when I need the code, I shouldn't disturb you saying that give me your code or vice versa, correct, right? That shouldn't happen. So that is the reason what we should do is we can keep it in a server with the help of version control system. Okay, so why in a server? It's a common place so that if your system get crashed, you can take the code from the server and you don't need to like take the code from you. Let's say you are one developer, I am another developer. I don't need to ask you like give me your code. As soon as your work is finished, you can push that code to the server so that I can get it from the server. Correct, right? So that is the reason we actually keep it in a server, but with the help of version control system. Why version control system? Instead of manually pushing the code to the server, so manually we make mistakes and it takes some time. So that's the reason we use a tool to do that for you. So that's the reason we use version control system. That version control system, we are using Git as a version control system. Okay, there are many, but we will be learning Git. Okay, because that is widely used tool. Fine. And there are some differences anyway in detail we'll be learning in the course. Fine. Now, yes, you are storing the code in the Git with the help of in the server with the help of version control system. Now, deploying the application into the dev environment is the responsibility of the developers. So they will be deploying the application into the dev environment once in a day. Why once in a day? Why not multiple times? See, I am talking about if there is no DevOps process exist, then what will happen? Okay, so yeah. So now they will be deploying the code once in a day. Why once in a day? Why not multiple times? Because their core job is to develop, not to deploy. Correct, right? So they will be working on development work, and in the evening before they leave office, like 5:30 or 6 p.m., they'll deploy the application, then they leave. Okay, fine. Now, at that time, if they encounter any issue, then everyone in the team should sit and fix that particular issue. Why everyone in the team? Because it's a project code, it is not one developer's code. We don't know where is the issue, who has introduced that particular issue. So we should understand. So that's the reason everyone in the team should sit and fix that particular issue, and they are supposed to fix that particular issue on the same day. They shouldn't come on the next day and try to fix that particular issue. Again, why is the question? The reason is we work on agile methodology. Now, what is agile? Okay, let's try to understand agile. So then we'll come back to this issue. Fine. As soon as you get requirements from the client, you are not supposed to directly start coding it. If you are directly start coding it, then you will end up having a number of issues, and definitely success rate will not be that much high. Correct, right? So that's the reason we follow some process called software development lifecycle. Definitely most of you would be aware of it. Okay, so SDLC we call it as. In SDLC we will have phases called requirement gathering, analysis, design, development, testing, maintenance, all that, correct? So in the requirement gathering, you gather the requirements. In the analysis, you analyze the requirements. And in the design, you design the project. I'm not talking about a web design, it's architecture of the project. Who does that? Architect will be doing it. And like when I say design, like what are the tools we should be using and how the data should flow, all that will be part of the design, and the outcome of that would be like HLDs and LLDs. Then using that, developers will be developing it, then it goes to the testing, then to the maintenance. Now these phases can be implemented by using multiple methodologies, and two of the popular methodologies are waterfall model and agile methodology. Okay, now before we come to the agile, first let's talk about waterfall model. There are some limitations or disadvantages using this methodology. That's the reason we use agile. So what is waterfall model? So waterfall model says you completely finish one phase of the SDLC, then only you move to the next phase of the SDLC. You gather all the requirements, then you analyze all the requirements, then you design for all requirements, like that. Then you develop all that. So one phase fall into the next phase. One phase would be the input for the next phase. So that's why we say waterfall model. Okay. Now according to this, let's say there are 100 requirements, and you have like one year, like 12 months. So when do you complete the testing phase? Around 10th month and or 11th month. Correct. After development, testing phase comes. So then at that time you go for a testing, then you complete testing around that month. Now, till that time, you will not be in a position to take a feedback from the client. Am I correct? So, because after testing only you go to the client, right? Before testing, how do you go to the client? So after that, you go to the client and ask for a feedback. If client says this is not what I am expecting, I need these changes. If those changes are small, not a problem. But if those changes are major, big, then you will not be in a position to accommodate those changes. The reason is you are in the end of the project, you don't have time, and you might have spent all the money, whatever you got it from the client. Correct? So, but sometimes, I'll give you a small example. Sometimes clients think that whatever they are asking is actually a small change. We are making it as big. Fine. Now let's try to understand, not in a software manner, in a different manner, so that we can easily understand. So let's say there is one car manufacturing unit. They have manufactured around 10,000 cars. Okay, they are intended to be sold in Indian market. Fine. Now, for some reason, now they've decided, because of some legal issues or something, they've decided not to sell it in Indian market. They wish to sell it in UAE market. So there is a problem. What is that problem? Is in India, the steering will be on right hand side. In UAE, the steering will be on left hand side. Correct? There is a problem. Now the architect is actually breaking his head saying that, how do I solve this? Now someone from the sales department suggesting this architect saying that, why can't you pull this from here and fix it there? Why are you breaking it your head like that? Getting the point? Is that so easy? Why? Exactly. So it is not that you are pulling from here and fixing it there. Accordingly, the other parts of the vehicle are aligned in that manner. Am I correct? The engine and other parts of the vehicle are aligned in that manner. Okay, if you are replacing this, you'll have to replace others also. Correct, right? So that architect knows. But for outsiders, they think that what is there in that? Yes or no? Okay. So that is a actual problem. So that is the reason, like most of the projects in waterfall model are going to be failed. Like 30% is only the success rate in the waterfall model. If you really know what needs to be done, upfront everything, then only it becomes successful. Okay. So that's the reason people are using agile methodology. So what exactly agile says is, don't take all requirements at a time. Now we said like 100 requirements. Out of 100, take like 10, 15, 5 or whatever. And you try to execute this in short duration. That short duration can be like 2 weeks, 3 weeks or 4 weeks. Okay. Now that short duration, we call it as sprint. Okay. Now in this duration, you follow all the SDLC phases for only these requirements initially. Okay. Now you analyze, you design, you develop, you test, all that you do it only for these requirements. At the end of that particular period, you go to the client and ask for a feedback. If client says this is not what I have expected, I need these changes, you can definitely accommodate those changes, because you are not taking the feedback in the end of the project. You are taking the feedback every 2 weeks, 3 weeks or 4 weeks. Correct, right? So very often, so there will be multiple sprint. It's not like only one sprint you will have it. So multiple sprint. Now in the first sprint, if you are taking like 10 requirements out of 100, out of 10, like 8 are accepted by the client, 2 are not accepted. Now total will become 92 because 2 are not accepted. So for the next sprint, you take 12, 15, 10 or whatever, and again you execute, then you go to the client and ask for a feedback. It will be keep on repeating. Since very often you are taking a feedback from the client, you will be in a confident position and comfortable position, and there is 100% chance of executing the project successfully. So that is the reason we work on agile methodology. Is this clear? Okay, fine. It's like writing your semester exams instead of directly writing like final exams, right? So semester is at least like, see, 6 months, or most of the cases like minimum 3 months, 4 months will be there. But here I'm saying 2 weeks, 3 weeks, 4 weeks only. Correct, right? So that's the reason. Now, when I talk about agile, I am saying like 2 weeks or 3 weeks, 4 weeks, but most of the cases we work on 2 weeks only. I never worked on 3 or 4 weeks sprint. The reason is 3 or 4 weeks are almost a month. We should not be waiting that much time. So that is the reason. Okay. So when you say 2 weeks, it's 14 days. In that 14 days, weekends we don't work. That's why we are all here and having demo today. Correct, right? So then it becomes how many days? 10 days. Then 1 day is required to take a feedback from the client. Okay, so then it becomes 9 days. Then 1 day is required for integration test, even though some argue saying that no, from the beginning we do it, but generally it happens in that way. So that is the reason. So 8 days now. Half a day is required for planning the sprint, like what are all the requirements you should be taking for that particular sprint. Then it becomes 7.5 days. Within this 7.5 days, whatever the requirements you have taken for that particular sprint, you will have to execute thoroughly, correct? So we have very, very limited time. So now let's come back to the issue faced by development team members. I was actually saying in the evening before 5:30 or 6 o'clock, if they are trying to deploy the application into the dev environment, if they encounter any issue, they are supposed to fix it on the same day. They shouldn't come on the next day and try to fix that issue. The reason for that is we are working on agile methodology. Every day morning, every developer should take the latest code and work on it. Since there are some issues in that particular code, again in the morning they should be fixing it, then they're wasting the time there. So instead, they should do it in the evening and they should leave office. Correct, right? Now let's say they were there in the office like 9:30 or 10 o'clock. The very next day, they'll come late to office. Yes or no? If not like 2 or 3 hours, at least like half an hour, 1 hour. Correct? Now, if there are 6 developers, if each person is coming like 1 hour late, minimum 1 hour late, then we are losing 6 hours there. Correct? So, 80% of one man day effort. We work 8 hours per day. or 9 hours maximum, correct? So 80% of 1 man day effort. If this is happening one day, we can adjust. But if it is keeps happening, then what will happen? Then you will not be in a position to deliver it. Forget about fastest delivery, not even a delivery. Yes or no? Okay, so that is a problem faced by development team members. Now let's focus on operational team members. Now, as I mentioned, operational team members are admins. They are like the responsible person to deploy the application in test UAT and production environments. Even though they are responsible to deploy the application into those environments, there are some configurations only developer would be knowing it. For example, connection strings and other stuff. Okay, so logging mechanism, all that. So that is the reason they both sit together and they'll be writing the instructions saying that this is how it should get deployed into those environments. Correct? Now, using that instructions, operational team members would be deploying it. So while deploying it, if operational team members encounters any issue, then operational team member tries to approach development team member saying there is a problem, can you help? If now development team member says I am into agile, I am working on my own task. So as soon as or whenever I get time, I'll assist you. If that whenever comes quickly, not an issue. Otherwise, again it comes to delivery only. Yes or no? Okay. So client would be watching. It is not getting deployed. See, no one is trying to waste the time here. They are working for a project. Both are working for a project. They are not wasting the time, but still it is happening. That is the issue here. Correct, right? Now we need to find a solution for these two issues. Fine. Now the solution is if the development team member and the operational team members communicate and collaborate with the help of automation tools, then we get a solution. The communication and collaboration between the development team members and operational team members with the help of automation tools is DevOps. Okay, so you might have seen the logo Dev and Ops, right? Correct. So left hand side Dev, other right hand side Ops. Okay, so that is DevOps. Theoretically, it's fine, but practically, how do you resolve this? I'm saying automation, correct? But how do you resolve this? Let's try to understand. Fine. So what is the first issue? They are trying to deploy developers before they leave office around 5:30 or 6 p.m. in the evening. And don't do that. Each time developers push the code, you try to take a build. Meaning, let's say there are 6 developers and I am one among them. Till 11 a.m. everything is working as expected. Now I am pushing the code at 11 a.m. Now if any one of the developer tries to take a build at that time as soon as I push it. So if there is any issue in that build, if that developer informs everyone saying that there is a problem in the build, so everyone knows at that time who has pushed it. I pushed it, then I am the responsible person to fix that particular issue. Yes or no? Yeah. So then others can focus on their own task. But there is a still problem in that solution. What is that problem? Developer's job is to develop it. Okay, but this particular developer is trying to take a build. It comes is part of the deployment, correct? Now there are 6 developers. Let's say each person is actually trying to push 3 times a day. It becomes 18 times a day. All 18 times, if any one of the developer is trying to take a build, then that person will be working on only on the deployment activities, not on the development activities. Then either to do the deployment or development, you need to hire one more person. If you are hiring one more person, then automatically cost would be increased. So we are not supposed to do that. Yes or no? So what is the solution? Correct, right? Now the solution is we should automate this. Manually, we shouldn't be taking it. We should automate it. So how do you automate is the question. To automate, we use a tool called Jenkins. We use a tool called Jenkins. Okay. I'm not saying this is the only tool we have it. There are n number of tools, but this is widely used tool. Okay, and it is open source tool. So you don't need to pay for it. That's the reason. Okay, there are like you have like Azure DevOps, Circle CI, Bamboo, n number of, even in Bitbucket you can have it. N number of tools are there. But we will be learning Jenkins. Now, using this Jenkins, what exactly we do? We create jobs. We create jobs. Jobs usually triggers by itself. You don't need to initiate it. Okay. So in that job, meaning as soon as developer push the code, this job will be triggered. Think in that way. Now, in that job, what exactly we do is we actually first take the code into the server wherever it is Jenkins is running, correct? Let's say I have written Java code and I from the Git I'm actually taking that particular code into the Jenkins server. Now I have the project code with me. Okay, before I get into that, you need to understand two things here. Deployment is equals to build plus release. Build plus release. Okay, in the build you will have compilation, unit testing, and code coverage. Okay, reviewing the code. So then if there are any automated test cases that can be added, sometimes in the release we'll do it, but here it's better to do it. So then you generate archive files. I'll explain in detail each one of them, but I'm just saying as part of the build, all this you will get it. Okay, then you release it. Once you get archive files, then you release, meaning into the related environment you actually keep the archive files, so then users can use it. So that is build and release. Fine. Now I am talking about a build process. Okay, now you take the code into the server, into the Jenkins server, then you first compile the code. Now how do I compile the code? For example, if I am using Java application, I'm not saying DevOps is tied to only Java. It can be for any of the applications as long as you know the build management tools. Okay, fine. But I'm just taking an example of Java. Fine. Now for Java, we use Ant, Maven, or Gradle as build management or project management tools. So why do you need this is the question. So we need to compile unit test to do all that. We need this. Okay, in detail anyway, again, I'll be explaining that in the classes. But first, using this particular tool, you first compile the code. Okay, it depends on again the technology. If you are using .NET, you should be using like MS Build and .NET. Okay, it depends on the technology, the related build management tools, you should be using it. Okay, fine. Now, using the Maven or any other tool, you first compile the code. Compilation meaning converting your source code to mission understandable language is compilation. Everyone knows about it. So then after that, you go for unit testing. Unit testing meaning it is not a feature test or functionality test. It's a function test. Function test. Okay. Function meaning developers will be writing some functions for the reusability. Okay. Now to verify whether those functions are working properly or not. So then we write unit testing. Again, I'll explain in detail later. So let's say there is a function called add a comma b, and to test that particular function from some other function, what do I do? I'll call like add 2 comma 3 and I'll expect 5 as a return value. If I'm getting 5, then it is working as expected. Like that, you write unit test cases. So that can be configured over here in this particular job. After that, you go for Sonar Cube. What is Sonar Cube is the question. So generally when you are working for a project, there will be multiple developers and each one will be having different levels of experience. One will have 2 years, other will have 5 years, someone will have 10 years, like that, right? So you cannot expect everyone to write like same code or same kind of code or performance oriented code, whatever tech lead is interested in. Correct, right? So that's the reason generally tech lead or someone will be reviewing the code. So then only they'll be merging the code. But since we are working on agile methodology, it is difficult for them to review line by line. So that's the reason that can be automated as well. Okay, so how there is a tool called SonarQube. Using this particular tool, what do they do? There will be some rules in that particular tool. For example, for Java, there are around 600 rules. For C Sharp, there are around 450 rules. Using that particular rules, this tool will review the code. If there are any deviations, this tool will captures those deviations. Then developers can log into that particular tool. Then they'll actually fix that particular issues. Okay, so these are all code review issues. Fine. So then again they'll push the code. Again the same process will happen. Fine. That can be included over here. So then after that, if there are any automated test cases that can be configured, people will be using like Selenium and all. So using that, so that automated test cases, they can have it, that can be configured. After that, you actually generate the archive files. For Java, we actually generate jar, var or EIR files. So what is this? Jar, var or EIR is the question, correct? Archive files, meaning let's say I have 100 files with me. I wish to share it with you. Then how do I do? I'll zip it and send it, right? So here I have 100 Java files. Now I convert it to bytecode or something after compilation. Now I get like 100 class files. Now how do I share it with some system, or as a one file I wish to run it? I cannot run one file at a time. As a one project, I should be running it. So to do that, to create as a one file, we do all this. Jar, var, or EAR files. There are different types of applications in Java. Accordingly, you generate this one. Okay. So then you will be pushing this into Artifactory. There will be something like JFrog or Artifactory will be there. So it's like you are keeping the code in the Git, right? Like that, these archive files, you will keep it there. Whenever you need to deploy, you can take it from there and you can deploy it. Okay. So till that, whatever you do it, this we call it as continuous integration. Continuous integration. So when exactly this is happening? Each time developer push the code. If 100 times developers are pushing the code, all 100 times this will happen. Okay, at any given point of time, this code is a deployable code because you have done all this, right? You compiled it, unit tested, automation, everything has happened. So then it is, you can deploy it. Okay, so that is why we call it as continuous integration. Fine. So at any given point of time, if you get any issue, then you send a notification to the development team member in this process so that they'll understand the issue, they'll be fixing that particular issue. Okay, it can be notification, can be an email or Slack message or anything, so that easily they'll get to know and they'll be fixing that particular issue. So using this process, the first issue is resolved. Now you are not taking the build in the evening 5:30 or 6 o'clock. Yes or no? So automatically this is happening. Except deployment, everything else is happening. Correct, right? So they can deploy because everything is done. Okay. So now what about the second issue? Second issue, what is the second issue? They are trying to deploy the application into the other environments like test UAT and production environments. Yes or no? Even for that, why can't you create one more job? It's not that in Jenkins you can create one job, right? You can create multiple jobs. So even in that particular job, let's say I am deploying an application. It's a web application. You'll have something like Tomcat. It's an application server. Okay, so for web applications, you must use this, then only you can deploy it. So to do that, you create one more job. This var file you deploy into the Tomcat. For web application, we generate var file. Web applications are the one which you can able to browse, correct, right? So those are all web applications. Those are all shared applications. Shared meaning multiple users can use at a time, correct, right? So to do that, we need Tomcat. So to deploy that var file into the Tomcat, you create one more job. That job, we call it as CD. CD stands for continuous delivery or deployment. So both are deployment only, but there is a thin line between those two. Deployment meaning as soon as developer push the code, you deploy.
Very rarely it happens because thoroughly it should be tested, everything should happen. So if everything you have configured properly, meaning 100% unit test coverage is there, 100% automation testing is there, 100% sonar cube is covered, then you can deploy it. But very rarely it happens. So that is the reason we follow continuous delivery. Even that is also deployment, but in the continuous delivery, there will be a manual intervention. You need to take permission from someone to deploy it into other environments like test manager or the product owner or someone, then only you deploy it. Okay, so that is continuous delivery. So using these two, the first issue and second issue both are resolved. Correct, right? So now developers can focus on their development activities, not on the deployment activities. Yes or no? Because it's automation. Okay, so the same thing for these guys as well. Okay, so in this process, first you learn Git, then you actually learn Linux commands. Why do we need to learn Linux commands and the shell scripting is, so 70% of the servers are running on Linux. So that is the reason to operate that systems, you must learn Linux. Okay, so then the shell scripting. Fine. So it's important. Then you will learn Java and Node.js build and release part. I am not talking about coding. Okay, I am talking about for DevOps what is required. Understood? So that part. Fine. And it is good to learn any one language. It can be a Python, it can be C# or something. Okay, but it is not included here. So you can learn separately. Okay, that also. Fine. So why is it required? I'll explain later. So if you are after the course, you can come to the institute, and I own a small company as well. So I am working on some real-time projects. So .NET real-time projects. So and Angular as well. So you will get a chance to work on those real-time projects. Nowhere else you will get that. So that means I'm covering three. Outside generally they cover only Java, but I'm covering three. Okay, fine. Then you learn Maven and is a world technology. Gradle I don't teach it due to the time constraint. So I am teaching Maven. So then you learn SonarQube, then you learn Jenkins and Tomcat. There are other tools also. I'll come to that tools. Okay, before that, any questions, anyone? Okay, then let's move ahead. If there are no questions, fine. Before I come to the other tools in DevOps like Docker, Kubernetes, I'll explain that. But I wish to explain about cloud platform, which is AWS. Okay, so there are others also. First, let us try to understand why do you need cloud platform, then we'll come back to this one. I mentioned deployment. So you can deploy it in one or multiple servers. Most of the cases you will be deploying it in multiple servers only, not in only one server. The reason is if you are deploying it in only one server, if that server goes down, if that server itself crashes, then your application goes down. Correct, right? And also based on the user base. So let's say one server can serve only 250 requests and you are getting like 1000 requests. You can't use only one server, multiple servers must be there. So that's the reason you deploy your application in multiple servers. Take an example now. Let's say you are working for an e-commerce application and you deployed that application in the on-premise servers. What is e-commerce application? You are actually selling some items, let's say mobile accessories, mobile devices, something. Think in that way. So now you deployed that application in the on-premise servers. On-premise meaning your company owned servers. Okay, so everything is working as expected. Now you are expecting like 10,000 requests per second, and think that one server can serve like 1000 requests per second, and that's the reason accordingly you deployed it in 10 servers. Yes, everything is working as expected. Now in December there will be some offers, right? So even I think day before yesterday also there was a Black Friday. Even though it was not December, there was some Black Friday offers like that. Even in December, there will be many offers. Now, at that time, you expect more load. User base will be more. N number of users will be using it at that time. Now, let's say you are expecting 20,000 requests per second at that on that month. Now, for 10,000 requests, 10 servers. For 20,000, you need 10 more, right? Correct? But you need those 10 servers, 10 more servers only one month. After that, you don't need it. Once offers gets over, again you will come back to that only. Correct? Only for 1 month, buying those servers and provisioning it in on-premise in your company, that's not cost effective. Meaning, after 1 month, if you're trying to sell those servers, you don't even get 50% nowadays. One day old also old only. Correct? And you need to have some physical space for that servers. Let's say I'm occupying this much space for 10 servers. For 10 more servers, same space you needed. That physical space is required. And also, you need to run those servers 24/7. Correct? With security. And you need to have some manpower to manage those servers. Only for 1 month, if you're trying to hire some person, 1 or 2 persons, difficult to get it. Even though you are getting it, you need to pay more. These are all the practical issues. Correct, right? But sometimes it is also difficult to predict the number of requests. I am saying 20,000. How can you exactly say 20,000? It can be more or less. No? It can be 30 or it can be 15 or it can be 12. Correct? So, ideally what should happen? Based on the load, I need to have servers. So according to our example, if I'm getting 30,000 requests, 30 servers should be there. 15,000, only 15 should be there. Why? If there are 30 and you are using like 20 servers only, 30,000 requests you are getting, there are 20 only servers, then again the response time will not be quick. It takes some time because load is high. So ideally you should have 30. But let's say you are getting only 15,000 requests and there are 20 servers. It's more, right? I mean, like you are like not utilizing the resources properly. Yes or no? Okay, so it is not cost effective. So that's the reason people are using cloud platform nowadays. Correct, right? So cloud is like pay as you use. Let's say if I'm using it for 1 hour, only for 1 hour, I can have my infrastructure, or 1 month I can have my infrastructure. Only for that duration I'll be paying it. Then after that, see, I am not maintaining that infrastructure. Someone else is maintaining it. I don't need any physical space. And after 1 month, I don't need to worry about those servers. Yes or no? So it's like your cabs, right? Ola, Uber, and any other cabs, right? So only for the duration which you are using it, for that only you will be paying it. Let's say I'm using my cab as a cab for 1.5 hours. Till the time I'm using that particular cab, I feel owner of that vehicle because no one else is allowed. You are secure. Correct? And only for that duration you are paying. After that, you don't need to maintain that. You don't need to worry about it, forget about it. Same thing here also. No? Only for that duration you are using it and you don't need to worry about it. You don't maintain it. And from wherever you wish to connect, you can connect it with the proper security mechanism. Understood? And the very important point is scaling, auto scaling, meaning I was mentioning like 30,000 requests, I need 30 servers, 15 only. So ideal number of servers you can maintain in the cloud. How? There is a concept called auto scaling. Based on the load, it will be keep on increasing the count of the server. Again, it can come down also. Okay, so scale out, scale in, we call it as. Correct, right? So what is the benefit? If you are using more, pay more. If you are using less, pay less. No? Correct? So that is the reason people are using cloud platforms. Fine. There are n number of cloud platforms. We have AWS, Azure, CenturyLink, Bluemix, n number. But In the market, mainly leaders are AWS, Azure, and GCP. But AWS is in the top. Okay, 70% the market is occupied by AWS. Amazon Web Services owned by Jeff Bezos, correct, right? And Azure is Microsoft one, everyone knows. GCP is Google one, correct? But we will be learning AWS. Okay, so if someone is from Azure DevOps, I'll come to that. Okay, I'll explain what is in detail Azure DevOps, all that. So, but let's focus on AWS. There are two packages in this: DevOps with partial AWS. Second one is DevOps with AWS. Okay, in the partial AWS, I cover EC2, S3, auto scaling, load balancing, VPC, IAM. EC2 instances are virtual machines. Okay, you can have virtual machine even in your system also. Someone mentioned like VMware and all, using that. You can have your virtual machines in your own system. So even in the cloud, you can have it. Okay, very important. So EC2 instances are virtual machines. S3 is for unlimited storage, but object storage, there are other advantages as well. Auto scaling, load balancing, I just explained that. VPC is to have your own network in your cloud, and the public cloud, private network. Then IAM is to secure all your services in AWS. Okay, these are all comes under partial AWS. But if you are opting for full AWS, all the services which comes under solution architect certification. There will be many. Okay, so SNS, SQS, Lambda, API Gateway, CloudWatch, CloudFormation, CloudTrail, list with this big. Okay, so all that will be part of full AWS. Okay, I'm not saying when I say full AWS, all the services. The services which are part of Solution Architect Associate certification. Okay, fine. You can really go for certification as well because the course is designed for that. Now let's come back to the DevOps tools. There is something called Docker. What is Docker? Using Docker engine, you can create containers. Using containers, you can develop, deploy, and ship your applications. Ship meaning move from one place to another place, your applications. There is a difference between the virtual machines which are in EC2 instances and the Docker containers. The difference is when you are using virtual machines, you need extra operating system. But when you are using Docker containers, you don't need an extra operating system. It would be using your host system only bootable files required. Okay, so if you don't need an extra operating system, you will be saving the resources like RAM. Okay, other resources you don't need extra. It is all depends on again cost only. For microservices, Docker is extensively used. Again, what is microservices? We'll understand in detail in the classes. Okay, so now in detail about the Docker, you learn like how to create Docker containers, Docker images, manually automation, Docker networking, Docker compose, Docker volumes, all that you'll be learning in this course. Fine. So then after that, you learn something like Kubernetes. So why do you need this Kubernetes? This is a container orchestration mechanism. To manage your containers in a cluster, we need Kubernetes. Okay, that means cluster meaning set of servers. Closely in one network, you will have the clusters, meaning the servers. Okay, to manage your containers in that cluster, you need this Kubernetes. In production, you need Kubernetes. Okay, fine. Extensively, we'll be learning it. See, every tool in DevOps is a version. Correct? But I take 2 weeks per tool and I'll be teaching in that particular 2 weeks whatever I could cover. Generally outside people covers within 2 or 2.5 months, but I am taking 3.5 months. Okay, so in that period whatever I could cover, I cover. Some people generally they'll have questions like whether you teach basics or advanced. I don't teach only basics, definitely more than basics, more than intermediate level also. Okay, but in that period, whatever I could, only Kubernetes people can teach 3 months. Getting my point? Okay, but I teach to the certain extent, definitely. Okay, but whatever I feel that you should learn little more on that, Okay, so I will let you know so that you can learn by yourself, because 70 to 80% anyway you will be learning it. That 20% learning is not a difficulty at all for you. Okay, in that also, if you get any questions, I'm happy to help you. It's like that. Okay, so then Ansible. What is Ansible? Configuration management tool. For example, let's say I have one server. In that particular server, I need to install one software, update one software, and create one file and provide some permissions to that particular file. If it is one system, yes, I can do it manually. I can connect to that and I can do it. But the same process, if I wish to do it in 20 servers or 50 servers, then it takes some time. It's not only takes some time, you make some mistakes. And troubleshooting also becomes a problem. So that is the reason you can make use of this particular tool. We call it as infrastructure as a code. Okay, so using this particular tool, you can configure, it can connect to each and every system. We write something like playbooks. Here we'll be using YML script and all. So using that, we will configure each and every system. This is also very important. You'll be learning this in this course. Okay, then you learn something like Terraform. Okay, think in that way. I just explained in the top like EC2, S3 auto scaling. Just take this example only. All this every day in the morning at 10 o'clock, I wish to provision it. Again in the evening, provision meaning create. Okay, so again in the evening 6 o'clock, I wish to destroy everything. Then manually, if I'm trying to do like every day the same process, it takes some time, right? Fine, even though you have the steps ready, you need to execute it, it takes some time. Correct? But you can use this particular tool, and again, this is infrastructure as a code. So you can simply execute this one. You write all the instructions, what is required in the Terraform to provision it. So it will provision it for you. In the morning, you can automate as well. See, for me, DevOps is all about four things: infrastructure maintenance, configuring the servers. Okay, so then configuration, I would say, which is Ansible we are doing. So then the deployment activities, then the monitoring. Okay, I'll simplify that again. In the entire SDLC process, if some repetitive task is happening, if that can be automated, you should be doing it so that you could save time, because we are working on agile methodology. That is the reason you need DevOps. Is this clear? Okay, fine. Now you are using Terraform to provision the infrastructure. Okay, now there is one service called Cloud Formation in AWS also. Each and every cloud platforms will have their own services like that. But Cloud Formation will work only in AWS. But if you are using Terraform, it can be used for enterprise. Enterprise meaning, let's say, I'm not using only one cloud platform. I'm using like Azure and AWS both together. And I need to have one script only to execute in both. Then I can go for Terraform. That is the reason people are learning the Terraform. Is this clear? So these are all the tools and the services which are part of AWS. You will be learning as part of this particular course. So DevOps, yeah, monitoring. I am not, earlier I used to teach like Nagios, okay, and all. But for monitoring, I'm not teaching, but I will be definitely teaching in AWS CloudWatch. CloudWatch will be for monitoring. Okay, so because due to the time constraint, I have not included Splunk and other stuff. Okay, so that you can learn by yourself. It won't be a big deal actually. Okay, so earlier I was not teaching like Terraform and all, because Terraform is mandatory. That's the reason monitoring. CloudWatch definitely I teach extensively. Okay, so now DevOps with partial AWS is actually like duration would be for this would be 3.5 months. 3.5 months. 1 hour per day in the morning, all weekdays. Okay, so initially we'll start with like 8 to 9. later on it will be like either 9 to 10 or 7 to 8 in the morning. Okay, fine. So then DevOps with full AWS. DevOps with full AWS is also like 3.5 months, but 2 months, 2 hours per day. Remaining 1.5 month, 1 hour per day. Because we should cover AWS also. That's the reason. Okay. So as I mentioned, once this course gets over, in this course I am teaching practically Java, Node.js and everything, but you'll get also a chance to work on .NET real-time projects. I don't keep, I'll take all the questions, sorry. So I don't keep any time duration for practical exposure. You can be there till you get a job here. There is no time constraint, like 1 or 2 months. I'm not saying that. First, you should complete this, then you can come to the project and you can work on real-time project definitely. Okay. And there are many people. See, the reason why sometimes people think that, see, most of you are showing some experience. You need practical exposure. Then only you can sustain in a job. That is first point. Correct, right? The second one is, even as a fresher also you need it, right? Correct. Later on you will be working on these tools only. If you don't have practical exposure, even as a fresher, how do you work on it? Because you are showing I learned all this. So then how do you work on it? So that is important. Nowhere you get that exposure. Okay. And online I can't do that, because personally you should be here, because it's I can't share that code with you. So that is the reason. Okay, fine. So that is about it. Now, definitely daily recordings I'll be sharing to everyone, whether you are attending offline or online, does not matter. I'll be sharing in the Slack. Okay, so that is about it. Now, I'm happy to take all your questions. Before that, I'm just stopping the recording and then I'll take the